Hello and welcome to this Java Break with Basis. Today's topic is how to make a view work for you, or more particularly a BBjHtml view work for you. Let's have a look at our agenda. It's a fairly short one. We'll review the functionality that we get from the fact that BBJ is built on top of Java, and then we'll talk a little bit about JavaScript, the most popular language according to GitHub. And then we'll summarize what we've covered today and take your questions. With the latest version of BBX, we have access to the most powerful language in the world, Java. There's an enormous repository of Java libraries, and many are open source, and those are available to your applications to augment, and we've been doing this now for close on 18 years. Let's review a few of the Java libraries that we've already leveraged with the BBJ utility set. Firstly, we have the email and the fax utilities. Email is an open source component. The fax utilities have a very small paid component attached to them. We can export to Microsoft file formats through the poorly obfuscated interface, or POI, open source library. We also have the Lucene search, Google-like search capability from the Apache open source community. And then probably the piece de resistance is our BBJasper print preview capability that allows us to view, export, save in Google Docs, a report generated from the WYSIWYG report writer tool that's available as an Eclipse plugin. It allows us to preview reports, search those reports, print them, save them to PDF, export them to Microsoft Office format, etc. And the latest one that I thought worthy of mention is the BBJ Doc Viewer plugin, which leverages an open source library to be able to give you the ability to view a document, for example, such as a PDF on screen, leveraging the capabilities of Java with your business basic applications. Well, what about JavaScript? According to GitHub, the most popular programming language for desktop and mobile web applications. Well, we're now going to give you access to this most popular language, JavaScript. Similar to Java, there is an enormous repository of JavaScript libraries, many of which are open source. And these are also available to your BBJ applications now. Let's have a look at some examples of native JavaScript events in BBjHtml view. So the request put out there several years ago was for us to provide access to JavaScript events in the BBjHtml view control. That was enhancement request number 25114. To integrate BBJ with HTML controls in a BBjHtml view and get native JavaScript events. The solution was implemented in BBJ 17 and is available from that release forward. Well, let's talk about the BBjHtml view control. Some of you may not be aware of what it can do and what its power is. Well, it's enormously powerful. It's a complete web browser. It supports HTML5, CSS, and JavaScript. It's available for both the desktop in GUI and for the browser user interface on the desktop and in mobile devices, where there's no need for Java to be installed. The view really understates its capabilities. As a fully featured web browser, it can do a lot more than just view data. It provides a user interface to work with the data, manipulate it, enter new data, save it, and review it. The BBjHtml view control can actually be transformed into a JavaScript control. Our demonstrations will reveal all. So what have we delivered by resolving that enhancement request? BBJ and JavaScript can now communicate with one another. BBJ can inject client JavaScript code. BBJ can execute the client JavaScript code and return a value. JavaScript can communicate with BBJ via a callback event. And most importantly, the HTML view works in both BUI, the browser user interface, and GUI, the graphical user interface, in your thin client. It handles the HTML, CSS, and JavaScript equally well in both of those environments. Just a note though, it's easier to test and debug in BUI because we can make use of the browser's developers' tools, which otherwise aren't immediately accessible in the graphical user interface environment. The implementation is a little different between the two. In the browser user interface, you can register a standalone CSS file with your application. And as a result, the CSS and JavaScript is available to all controls within that browser user interface, both BBJ controls as well as controls generated perhaps by your BBjHtml view control. In the graphical user interface, You set the CSS in the content with the HTML. Each HTML view has its own CSS and JavaScript, and naturally you can't reach out and utilize CSS for the BBJ native controls. Well, what's new? We've had this technology around since BBJ 17. Well, new in preview from 18.10 onwards and fully supported in BBJ 19 is the Chromium engine. We've added an additional support for a more modern web browser in both BUI and GUI. It is by default enabled, but will gracefully degrade to JavaFX, or as is now going to be known, the OpenJFX, and then Java Swing. What are the benefits? The Chromium engine is faster than the JavaFX or the OpenJFX. It's updated more frequently and supports a richer set of HTML5, CSS4, and JavaScript. So let's look at some examples. We're going to implement a JavaScript calendar in BBJ. So we're going to use a jQuery calendar plugin. So how do we find one? We'll use our friend Google. So finding the jQuery calendar, we download and unzip the source code, write a BBJ program with a window, and put on that window a BBjHtml view control. Now what we have to do is integrate that jQuery calendar inside of the HTML view control. Firstly, we load the HTML view with a div per the plugin docs. So here is the code that you can refer to post this Java break. In this case, this is setting the JavaFX HTML view to be true. We would now suggest that you use the Chromium engine by default. And then we implement the addition of the HTML view to the window. And then we set a callback. When the BBjHtml view has loaded, we set the callback and inject the JavaScript library, jQuery or full calendar, etc. So on page loaded, we see that we clear the callback, set the new callback, and inject the JavaScript. What's our next step? Now we're just left to execute the JavaScript that instantiates the calendar. Pretty straightforward. Run the program and admire your handiwork. But we can do more. We can add more views, a month view, a week view, a day, or an agenda view. We can add events to the calendar, hourly, daily, multi-day. We add the ability to drag and drop events. We can have the calendar notify the BBJ program of an event change and execute some business logic. Let me hand you off to our engineering supervisor, Nick Decker, who's going to take you through the process of enhancing that jQuery calendar inside of a BBjHtml view.
We started off with a simple BBJ application comprised of a GUI window with a BBjHtml view control. Taking advantage of some of BBJ 17's new features, we injected the jQuery JavaScript library and a popular JavaScript calendar plugin into the HTML view control. After executing a line of JavaScript, we have a fully functional calendar that runs in both GUI and BUI. The full calendar plugin that we chose, though, is capable of so much more. It has a rich API that covers display options, time zone support, alternate views, a variety of different event types, and even user interactions such as clicking, hovering, selection, dragging, and resizing. That's pretty exciting, and our application can do a lot more if we go beyond the simple JavaScript that displays the default calendar. To start with, we'll include some calendar customizations to support different view types. Copying and pasting some of the demo code from the plugin into our BBJ program results in a souped-up calendar with a variety of different views. After looking into the calendar's API some more, it supports callbacks to execute custom JavaScript code in response to a number of different user events. This is a perfect opportunity for us to find out when the user wants to reschedule an event or modify its duration. And since we're in charge of what should happen when the user changes an event like that, we'll take the opportunity to have the JavaScript pass the information along to BBJ to demonstrate the two-way communication. After adding a few more lines of JavaScript to our BBJ program, we've told the calendar what to do when the user drags and drops an event to a different day. We can write similar code that keys off of its event resize calendar callback. So whenever the user extends or compresses an event's duration, then we pass that information to BBJ as well. Our BBJ program is pretty simple right now. So whenever we get an event from the JavaScript in the HTML view control, we'll display it in a message box to verify that our application is aware of the user's changes. With all of our callbacks in place, let's run our application again. This time, we can move an event, such as the buoy training, to a different day by dragging and dropping. After letting go of the event, BBJ displays a message box indicating that it's aware of our change. That worked great, so let's test our event duration callback. What if the buoy training is so popular that we want to extend it to run 3 days? We simply resize the event on the calendar, and BBJ responds by telling us how long the event now lasts. Notice that the calendar automatically shifted the dashboard training event on Friday to sit underneath the extended buoy training event. To revert our change, we drag the right edge of the event back to Thursday, and the BBJ message box confirms our change.
Thanks, Nick. What are the native JavaScript events in the BBjHtml view? Like CSS, JavaScript is handled by the client, so it gives you optimal performance, no round trips to the server required, and the JavaScript executes immediately. That gives us rapid response to user actions and no delays introduced by latency. That allows us to deliver smooth animations. Let's have a look at another example that really shows off those capabilities inside of the BBjHtml view control. Let me hand you off again to Nick to see that in action.
One of the benefits of using CSS and JavaScript for animations is that all of the code is handled by the client's browser. That means that animations can be defined at the start of the app and will be triggered and executed entirely on the client without requiring any round trips to the server. As a simple example, consider the CSS Hover effect. Our CSS defines both the normal and the hovered state of a button. The client's browser loads the CSS, recognizes the hover parameters, and, in essence, it makes a mental note to itself to pay attention to that control. That way, when the user hovers their cursor over the control, the browser knows immediately and changes the button's appearance. Let's take a look at an example of this by loading up our presentation launcher BBJ application. It displays TechCon presentations, one per column, with each presentation comprised of several topics. Each topic is listed as a row in the presentation column, and because we have the concept of the current presentation and topic, we visually distinguish the selected presentation and topic. To emphasize the current presentation, we increase the width of the column and ensure that all other columns are narrow. To further accentuate the state change, we grow the font size of the presentation title and darken the graphic background. Likewise, changing the current topic in a presentation reveals the topic overview while changing the title's font size and color. All of these changes are accomplished via JavaScript and CSS, resulting in silky smooth animations. And whenever we change a presentation or topic, the JavaScript notifies the BBJ program of the current selection. The BBJ program responds by displaying the selected presentation and topic text in the app's title bar. This notification mechanism keeps the BBJ side in sync with what's happening on the client, and the BBJ program can then launch the desired presentation on a double click or display it in an embedded window.
Thanks, Nick. So we've seen how JavaScript can communicate with BBJ via a callback event, gather relevant information in the JavaScript code, load an event or object with the desired information, and send an event or object to BBJ via two methods, basis dispatch native event or basis dispatch custom event. Now, our next example, we're going to have a look at a clock picker. So this is how we would respond to the onChange event and dispatch a native event to BBJ. So our goal is to integrate a time picker plugin with BBJ. So BBJ does not have a native time picker control, but the good news is there are JavaScript libraries out there that we can leverage to give us that functionality. Here's a before and after we've applied some CSS. In a minute, we're going to have a look at how we can deliver this kind of date picker control. Once again, let me hand off to Nick to show us how it's done.
BBJ supports dozens of different controls, but occasionally you may have a need for a very specific type of control that's outside of the realm of common controls. In some cases, you can build that control by combining 2 or more BBJ controls, or even by modifying the look and behavior of a standard control using some clever CSS. In this video, we're looking for a very specialized control that's specific to time entry. Sure, we could use a masked BBJ input end control, limiting the input characters to numbers and formatting the data in hours and minutes. But instead, we're shooting for a very graphical and intuitive way of entering starting and ending times. Since we want something that's easy to use and we don't mind coloring outside the lines every once in a while, why not use an analog clock for time input? Since we don't want to invest a lot of time into this, let's set some goals. 1. We shouldn't have to write a lot of code. 2. We shouldn't have to use the keyboard for time entry. 3. We should look into using a freely available library. 4. The library should work across all major browsers. 5. The library should work in a touch environment. And 6. The library should be modifiable in case it doesn't fit our expectations out of the box. We start by exercising our Googling skills and end up with a lot of potential candidates. Apparently, a lot of other programmers had the same need, and there are a variety of libraries that solve the input problem in very interesting ways. This one looks like a clock, but the 24-hour input and the bland colors aren't quite what we had in mind. So let's see how flexible it is. The options indicate that we can set the default time, set a 12 or 24-hour mode, etc. It also works in all browsers down to IE9, and touchscreens aren't a problem. The demo looks great. We can select the hours by moving a hand around the clock, and it allows for hours and minutes inputs, and we can toggle between the two. After downloading and exploding the zip, the next step is to integrate it into our timesheet app. Step 1. Set the HTML text for the BBjHtml view control that we're using to keep track of when the employee checked in. The clock picker documentation wasn't very helpful here. Sometimes that's the price of free software. But after looking at their demo source, we need to include an HTML div with a unique ID and an input tag. We also included an onChange event where we pass the input value back to our BBJ program via the basis dispatch native event mechanism. Step 2. Inject the JavaScript library contents into the HTML view. Step 3. Set a callback so that our BBJ program can react to a JavaScript event in the input control. Step 4. Execute a line of JavaScript to instantiate the clock picker using the unique ID from Step 1. And finally, Step 5. Have our callback code display the selected time in a standard BBJ message box to see if it works. Let's take it for a test spin. Clicking in the HTML view control causes the clock picker to display, so it looks like we didn't make any programming mistakes. We can select the hour by moving the clock hand, and letting go of the mouse button changes the display to minutes. We can toggle AM and PM if desired, select the minutes, and then click OK. The clock picker library then fills the input with the selected time, which triggers our onChange event and sends the time to BBJ. Our callback routine fires and displays the selected time in a BBJ message box. Through the magic of video, all of our code worked the first time, and we're now free to experiment. To improve our app, we'll add in some custom CSS, both for the BBJ side and for the clock picker side. Additionally, we'll make a couple of small improvements to the clock picker JavaScript code. The clock is huge, so we'll make it scalable, and our timesheet app will use a smaller version to streamline the input. The time display at the top of the picker doesn't contain the AM/PM designation unless you click on the AM/PM buttons, so we'll add that and make it clickable to toggle the time periods. After our changes are in place, we're ready to run the updated timesheet app. Our custom CSS has given our app's user interface an overhaul. We've darkened the HTML body's background color and changed the application's title bar. Our fonts are larger, bolder, and yet they don't take up much more space since we're using a condensed font family. The radio buttons, checkbox, and buttons at the bottom of the form have also undergone massive changes. Clicking in the Time In field brings up the clock picker as expected, but this time we dimmed everything behind the pop-up via CSS. The time at the top of the picker now displays the AM/PM designation automatically, and clicking on this field toggles a value, and the AM/PM buttons toward the bottom of the picker change to reflect the chosen period. After selecting the hour, we can select the minute either by dragging and dropping the clock hand, or by simply clicking anywhere on the clock face. Our timeout field is similar, so after selecting a time in and a timeout, our program computes the total work time and displays it in a read-only field. Our timesheet app works great, and the addition of the clock picker adds some character and makes the app fun to use. We were rather gutsy, delving into the world of HTML and JavaScript, but our experiment paid off considerably.
Thanks, Nick. What additional resources are available to you? Well, the Eclipse IDE is naturally enough your go-to environment wherein you can get access to the various plugins like the code editor, the window builder, the app builder, and the BBJ utility set. In addition, Eclipse offers many other useful plugins such as code versioning. To join the Basis IDE user group and wiki, go to our website and then navigate to the discussion forums, select the sign in, create an account, and then back on the discussion forums page, select the IDE user group. Go to the IDE user group wiki, and there you will see the source code, the timesheet demo source code, the full Calendar jQuery plugin demo, and the Workbench Info Grid demo. You can view these YouTube videos that we've shown you today and also direct perhaps some of your clients and your colleagues to this information. So in summary, what have we covered today? We've recapped the fact that for almost 18 years, we provided through our latest and greatest version of BBX access to Java and the full rich set of Java libraries that are available, many of them open source. And now we're exposing the access to JavaScript libraries. And we've shown you 3 examples today. We remind you they're available both in the browser user interface, where there's no Java, on the desktop or on mobile devices, or on the BBJ thin client in GUI, in the graphical user interface. You're only limited by your own imagination of what can be achieved. The source code is available for these 3 demos. Sign up to the IDE user group and get access to the IDE wiki and download and view that source code. It's time to take your questions.